Hello everyone, today we're talking about exponential functions, the second part of 4.1. First thing I'd like you to have down is the compound interest equation. A is going to be, the A stands for here, stands for the future value of the investment. So what it's going to be worth after a certain number of years. P, the principal, is how much money we're going to put in or borrow in certain instances. So the original money that we're starting with is always going to be 1. The rate, typically they're going to give you the rate in percentages. So you're going to have to take the rate percent and turn it into a decimal in order to use it in our equation here. And that's the R there. And then N is the number of times the interest is compounded annually. So they'll tell you compounded monthly, compounded weekly, compounded semi-annually, compounded annually would just be one time a year. So that's our N. We plug that in for the N here and the N here whenever we determine the number of times it's compounded in a year. And then T stands over here by itself as being multiplied by our N in the exponent. And that's just the number of years that you're investing that money or borrowing that money. So let's do an example. They have told us that $4,000, that's important, so I've underlined it. That's our initial right there. $4,000 is borrowed at a rate of 16%. So that's how much we're being charged to borrow that money. And it is compounded quarterly. Find how much money is due at the end of each of these 3 time frames. So, let's start right off with A. I'm going to write my equation down. That's an R raised to the N times T. And then just plug in what I know. My initial principal, 4,000. My rate was 16%, so 16% as a decimal is 0.16. Right? Just take 16 divided by 100. That'll give you the decimal, or move the decimal place 2 spots. We should know how to turn percents to decimals. N is the number of years. In this case, I'm going to start with A. So, N is the number compounded in a year, and it says compounded quarterly. So quarterly, if you think of like a quarter money, 1 quarter, that's 1/4, right? So it's compounded 4 times a year. So my N is 4, and then my N that's 4 also goes in the exponent, and then it's also multiplied by, so that N is multiplied by the number of years, 4. That's where I was getting stuck initially. So we have 4 because it's compounded 4 times in a year. And then we multiply that by the number of years. And when you do this, after 4 years, you're going to owe $7,491.92. So you're going to owe that much money after 4 years of borrowing $4,000 with 16% interest. So that's A. B. Same equation, except instead of 4, now I've got 6 years. So same equation, everything's the same. We started with $4,000. Our rate is 16% still. It's still compounded quarterly, so it's still compounded 4 times a year. So my N is 4, but now I multiply that exponent by 6 instead of by 4. So after 6 years, you would owe $10,253.22. Here we should be, I just want to remind you, we should be rounding to the 100th spot. We should be rounding to 2 decimals because we're talking about money, right? You can only go to the cents. And finally, part C, same equation, same starting, right? We're still starting with $4,000. We still have a 16% interest. We're still compounding quarterly, but now we want to borrow that money for 8 years. So you will owe, after 8 years, $14,032.23. So there we go. That's our compound interest formula. So compound interest, because we're compounding it a certain number of times each year. And then they'll tell you how many years we're going to compound that money. Next thing I want us to have down. This equation is when we're compounding money, but continuously. So we're not compounding it quarterly or weekly or monthly. We're not compounding it a certain number of times each year. We're constantly compounding the money. So if they say compounding continuously, we're going to use this equation. Compounding continuously, we use this equation. If they tell you that you're compounding it a certain number of times each year, you're going to use the first equation. So they want us to, which of the given interest rates and compounding periods would provide the better investment? So, the top one, again, equation A equals P times 1 plus R over N times, raised to the N times T. Plug in what we know. Well, I'm going to figure out the total investment. They didn't tell me my initial, but I'm going to use the same initial for both of them, so it doesn't matter. I'm just going to say I started with $1,000. Right, let's say I started with $1,000 I want to invest. The one stays the same. The rate when I'm compounding semi-annually is 9.25%, so 9.25%, and as a decimal that's 0.0925 as a decimal. And compounded semi-annually, semi means twice a year. So semi-annually, my N is 2 because I'm compounding twice a year. And I'm just going to say after 1 year. And I'm just going to see which one gives you the most money after 1 year. The 9.25% compounded twice a year, or the 9% compounded continuously. And I just started with $1,000. I'm going to see what it does after 1 year. So after 1 year, compounding it semi-annually at 9.25%, your money is worth $1,094. Don't know why I did that. $1,094.64. So that's if you compound it semi-annually at 9.25%. The other now, we're at 9% compounding continuously. So that's where A equals P. The mathematical constant E, so that's the E I was telling you about in the first lesson, the first part of 4.1. That's the mathematical constant E, so just a number. And then E raised to the rate times how long we're going to let that money sit. So I'm looking for the total amount after 1 year. And again, my initial is 1,000, right? They didn't tell me that, but it didn't matter how much money I started with, as long as I started with the same. I'm going to see which one gives us the most money at the end. So 1,000 times E, and raised to the rate. The rate in this case is 9%, so 0.09, and that's 0.09 times T, which we said was 1 year. And remember that these should be in parentheses because it's the entire exponent. So E is being raised to 0.09 times 1. And when we compute that, your money is worth $1,094.17. So, if you had the choice to invest it semi-annually at 9.25%, or continually compounding interest at 9%, you can see that we're going to take the compounded semi-annually. Right here, it didn't make a whole lot of difference. It only made, certain number of cents difference. But if you had more money invested over more time, you would see a much bigger gap between compounding semi-annually at a higher percent than you would compounding continuously at a lower percent. So I would choose the compounded semi-annually. That's all the question was really asking. But it allowed us to use our compound interest equation and our continuously compounding interest equation. Finally, we have a 50-gallon barrel. It's filled completely with pure water. Salt water with a concentration of 0.3 pounds per gallon is then pumped into the barrel. The resulting mixture overflows at the same rate, so the same amount we're putting in comes out. The amount of salt in the barrel at any time t, so at any time while we're putting this water in, the amount of salt is given by this equation, where t is measured in minutes and Q of t is measured in pounds. So the number, or the amount of salt is measured in pounds. So the first question asks us, how much salt is in the barrel after 5 minutes? So in this case, what we're substituting in, 5 for t. So my equation was Q of t equals 15 times 1 minus e raised to the negative 0.04 t. So 0.04 times t, all of that is in the exponent. Plug in what we're now trying to compute. We're trying to compute how much salt after 5 minutes. So I'm doing Q of 5. I'm plugging a 5 in wherever I see a t. That gives me 15 times 1 minus e to the negative 0.04 now times 5. When I do that, Q of 5 is 2.72 pounds. So after 5 minutes, there's 2.72 pounds of salt in my barrel of water. Then again, they want how much salt is in the barrel after 10 minutes. So it's the same equation, except now I'm doing Q of 10. So I take a 10 and plug it in wherever I see a t. So I get 15 times 1 minus e raised to the negative 0.04 times 10. And after 10 minutes, I have 4.95 pounds of salt. So I've answered A and B, how much salt is in the barrel. 4.95 pounds after 10 minutes. Part C wants us to draw the graph of the function. So I can just type this in to my y equals on my TI-83. Obviously, instead of Q of t, that's my y. And instead of t, that's my x. So you can go ahead and plug it into your TI-83, and you're going to get a graph like that. So I graphed it. This looks a little bit neater than the TI-83 would be, so I graphed it this way on Desmos. So we can kind of see that our line, right, is never going to go past a certain amount. So that leads us to the question D. Use the graph to determine the amount of salt in the barrel. Determine the value that the amount of salt in the barrel approaches as t becomes very large. So as my time goes on forever to infinity to the right, so if I just kept letting this pipe or this water enter the barrel at the same concentration, after I get a certain amount of time out, what is my amount of salt approaching? So I have also graphed that line. And you can check this out on your TI-83. You can go way out here to 100. You could go way out to 1,000 for x. And even at 1,000 minutes, it's not going to cross 15. Right? So it's never going to cross the line y equals 15. Well, why is that? Let's go back to our original question. So it says the concentration of the water that's being pumped into the barrel is 0.3 pounds of salt per gallon. Well, it's only a 50-gallon barrel. So if the concentration is 0.3 pounds per gallon, you just take 0.3, multiply it by 50, that's going to approach 15. So 0.3 times 50 gallons is 15 pounds of salt. So go ahead, try the examples that accompany this in the PowerPoint, and we'll talk about it in class tomorrow.